All right, systems of equations. So we're going to figure out what a system is, what is a solution to a system, and we're going to start solving systems by graphing. Okay, so a system of linear equations is two or more equations that contain the same variable. Okay, so in 8th grade, we really focus on systems with just two equations. Okay, so we're going to look at a big picture of things we could look at throughout the unit that has real life situations going on, and then we'll kind of take those away to look at just the math. So we're talking about two cab companies, a yellow cab company versus a blue cab company. Okay, the system here, we can see we've got our two equations, which makes the system. Our variables are the same, x and y, and they both represent the same thing. Okay, in each of these equations, x represents the number of miles. Y represents the total cost. Okay. So a blue cab is represented with a slope of 1 and a y-intercept of 5. So we can see that that's already been graphed here, meaning I'm paying $1 for every mile plus my initial value of $5 just for getting in the cab. The yellow cab has a slope of 2 and a y-intercept of 2. So we can see that that's being graphed here, meaning I'm charged $2 every mile, but my initial fee for just getting in the cab is only $2. So why might we want to look at a system of equations? Well, we might have these questions to answer. So which cab is cheaper? Okay. And the answer is it actually depends on the number of miles you're going to travel. So if we notice before this point of intersection here, the blue line is higher up on our graph, which means that's actually the more expensive one, right? For 1 mile here, we can see I'm paying almost $6, where for the yellow cab, I'd only be paying $3. So before this point of intersection, my yellow cab would be cheaper. But after that, notice my yellow line is above the blue line, which means after this point of intersection, those number of miles would be cheaper in the blue cab. Okay. When do the cabs cost the same? That's right here where they intersect. So if I write the coordinates for this point, I've got 3, 8, which means 3 miles cost me $8. Okay, in either cab. Whether I'm in the yellow cab or the blue cab, I travel 3 miles, it's going to cost me $8. Okay, so that's kind of just one of the things we might be able to do with some systems. So for the next couple videos, we're going to take that story away and focus on just the math, and then we'll bring the story back into it. Okay, so what is a solution to a system? A solution to a system is an ordered pair. So when we've been solving just one equation in the past, it's been like x equals 5 or y equals 2. We actually have two parts. You have an ordered pair. You have an x solution and a y coordinate solution. Okay. For it to be a solution to a system, it must satisfy both equations, meaning it works in both equations, and it's where the two lines intersect. So we already looked here on our graph from that last problem we just looked at. They intersect at the point 3, 8. So it's where the 2 points intersect. For it to work in both equations, that means I'm taking my x and plugging it in. I'm taking my y and I'm going to plug it in. So if I do that over here to the left, that means 8 is supposed to equal to 1 times 3 plus 5. Okay, so 1 times 3 is 3 plus 5. That is 8. So it works in my first equation. I plug it in my second equation. We get 8 is equal to 6 plus 2. 8 is equal to 8. So it works in both equations. It makes both statements true. So that just confirms, again, it's where the two lines intersect, which means this is my solution, 3, 8. All right? So here's another example. The system has already been graphed for you. Take a second to write what you think the solution is. So solution is where they intersect. So make sure you're writing your coordinates in the correct order. It's always the x coordinate, comma, the y coordinate. Okay. And because some of you might accidentally do that backwards, we always want to check our answer, which is where we're plugging these into our equations. So this first one, my y value is -4, my x value is -2. Does this make a true statement? Yes. So it works in my first equation. For it to be the correct answer, it has to work in both. So I'm going to check the second one now. Y is -4, x is -2. So -4 is equal to -1 subtract 3, which is -4. Okay, so this is our solution, -2, -4. Adding in one more step now. I've not graphed the system for you, so you have to graph it and write the solution and then check your answer. So pause the video and give it a try. So this first equation graph, we have a y-intercept of -7, slope of 2. Now you really want to extend your line all the way because we have no idea where the other line is going to intersect. So I really fill up my graph here. So here my y-intercept is 0. So I'm going to start at the origin. Up 1 over 4, up 1 over 4. So right now I don't have to extend the line back this way because I already found where they're going to intersect. So, and then I write those coordinates, x, comma, y. That's what I think my answer is. Of course, then we're going to check. So this first equation, y is equal to 2 times x, subtract 7. 2 times 4 is 8, subtract 7, which is 1. So my first equation works. Second equation, 1 is equal to 1/4 times 4. So that simplifies to 1 is equal to 1. There's my answer. Pause the video and try this one. So my first equation here has a y-intercept of 6, slope of positive 2 over 3. 2 over 3. And then second equation, y-intercept of -2, slope of -2. So remember that's -2 over 1. So found my point of intersection there. -3, comma 4. So if you are ever graphing and they don't meet at a pretty point, for 8th grade, I'm going to say you probably graphed it wrong. Okay, systems don't have to meet at nice, pretty points, but because this is your first time learning and dealing with these, that's kind of a good way to tell you probably made a mistake in 8th grade. So again, then to check our answer, we'd plug these in, my x and my y. So 4 is equal to 2/3 times -3 plus 6. So I'm going to put a 1 on the bottom. Remember, multiplying fractions, you go straight across. So that's -6 over 3 plus 6. -6 over 3 is -2, which is 4. So my first equation works. Second equation, y is equal to -2 times x, subtract 2. So negative times negative is a positive. Subtract 2 gives me 4 also. So pause the video and try this one. So I hope you realize that this first equation is not in slope-intercept form. So before you can graph it, you need to rearrange it, which means I need to get y alone. So I'm canceling out that 3x. which means now I have y is equal to 3x plus 6. Right, so now if I graph it, my y-intercept's 6, my slope is positive 3. Again, really filling up my graph here because I don't know where it's going to intersect. Y-intercept of 8 for the second one, and a slope of 1. It actually intersects way up here, 1, 9. Okay. And because of time, I'm not going to go through checking your answer. Realize if you did not rearrange this and you got a different point of intersection, it probably would not work when you check your answer. All right, so here's another system we're going to look at where I've already graphed it for you, but do you see any point of intersection? No. So my question is, will they, because lines go on and on forever, will these lines ever intersect, either going down this way or up this way? Are they ever going to intersect? And your answer should be no, okay, because they both have the same slope, right? They both have a slope of 1. So they're both starting at different spots, starting at 2, starting at negative 3, and they're both going up 1 and over 1. They are never going to meet. So if they never meet, that means they don't have a point of intersection, which means that this system has no solution. Okay. So that means we have the same slope, different y-intercepts there. Okay. Let's look at this system together. So if I graph this first line, I've got 2 is my y-intercept and a slope of negative 3. Okay, the second one is not in slope-intercept form, so I'm going to rearrange it. So y is equal to my negative 3x plus 2, which notice now this is the exact same equation. Which means if I graph the second equation, I have y-intercept of 2, slope of negative 3. It's the exact same line. So then what's our solution? Where do these two lines intersect? These two lines intersect everywhere, which means you have infinitely many solutions. Okay. They're going to intersect everywhere, on and on forever. Does this mean every ordered pair is a solution, though? No, because this point right here is not going to be a solution because it's not on the line where they intersect. But we still have infinite solutions because these lines go on and on and on and on and on forever. So you can always write another solution. So we can summarize the 3 different solutions we've just looked at. One solution, you have an ordered pair, the lines intersect once. Okay. No solution, your lines are parallel. Okay, so this means you have the same slope, different y-intercept. Infinitely many solutions, the lines intersect everywhere, they're essentially the same line, meaning same slope and same y-intercept. Okay. So let's take away the graph for a second and learn how to check a solution. So is the point 3, 11 a solution to the system? So to do this, again, it's basically what we were doing earlier in the video. We're going to plug these in for x and y. For it to be a solution, it has to work in both equations. So if I bring this first one down here, y is equal to 4 times x, subtract 1. So this is 12 subtract 1, which is 11. So first equation works. So check my second one. 11 is equal to 3 times 3 plus 2. 9 plus 2, which is 11. 11 does equal 11. So is this a solution? Yes, it works in both equations. So go ahead and pause and give this one a try. So I already see right here in this second one, 3 times 2 is 6. Subtract 5 is going to be 1. 1 does not equal 7. So it does not work in the second equation. So it's not going to be a solution. I don't even have to check this one. And pause the video and give this one a try. This one works.